Okay, guys, watch and listen carefully here. So in question number 1, we have Sisyphus, who's a character from Greek mythology. Zeus kidnapped his wife, and Sisyphus tried to rescue her, and his punishment for getting caught trying to rescue his wife from Zeus was that he should push a rock up a hill for all eternity. He was actually in the very first Red Bull gives you wings ad. Okay, like the very, very first one. Okay, so we have this big rock, and it's being pushed up this hill. We know the hill is 800 meters long, and when he gets to the top of that, well, I mean the hill is endless because it's all eternity. But this first section of the hill, anyway, after he's gone 800 meters, will result in him having pushed the rock 247.21 meters. Okay, so that's what we know right now. Okay, we also know it's being pushed at a constant velocity. Okay, I didn't actually make you do this 18-degree thing. I gave it to you instead. All right, there's actually 2 ways to solve this. One really, really fast way and one much longer way. Okay, the really fast way is that work is a change in energy. All right, so we'll do that way first. So if they've got some kind of diagram or givens written down, okay, give them a mark. All right, work is a change in mechanical energy. Since there's no change in kinetic energy in this question, this work is actually just a case of a change in potential energy, right? Because that's all he's changing. We're going from the bottom of the hill to the top of the hill. So what we have then is that work will equal m times g times h final minus m times g times h initial, which is 0 because we're starting at the bottom of the hill. Okay, we're only trying to find the work, not the force, not the distance, or any of that. Okay, so all we have to do is go mass of the rock, 200 kilograms, times 9.81 times 247.21 meters, and we have our final answer. So 200 times 9.81 times 247.21 meters. Okay, so we have 3 significant figures in this question because we didn't use the 18 degrees there because we didn't get it. So we will have 4.85 times 10 to the 5 joules. Okay. I'll go over that way. Yeah. Okay, in just a second. Although in the question that you guys, oh yeah, I did have the 18-degree angle there. Okay, so for that one then, there'll be 2 significant digits instead. All right, so the other way to do this is to realize that the net force is what in this question? Is 0. Sorry, I didn't tell you where the other marks came from. Second mark, third mark, fourth mark. Okay, if they did it using that method. All right, the net force is 0, which means the force applied up the hill is equal to which force acting down the hill? F parallel, right? We're moving it at a constant speed. We only have to push as hard as F parallel is pulling down. Somehow he's able to walk up a frictionless ramp. Don't ask me how, okay? It's Zeus's punishment. He figured it out, okay? So all we need to know there is that F net, okay, equals 0, which equals F parallel plus the force applied. So we just have to find F parallel because it's equal to but opposite the force applied. Okay, so I'm going to find F parallel, okay, using our usual calculations here. Okay, this side's F parallel, this is 18 degrees, this is FG, so it'll be 1,962 newtons for FG. So we'll calculate F parallel by going sine of 18 times 1,962. Okay, so we've got 606 newtons up the ramp, okay, as our F applied. And we're going to multiply that by the distance of the ramp, 800 meters. Okay, and oh, lo and behold, we get exactly the same number because it doesn't matter which way you do it, except that this way involves me calculating first off the force of gravity, then F parallel, okay, and then coming up with my final answer, whereas this other method requires me to go m times g times h and be finished in one step. I prefer the quick way. Well, then they're not going to get it right. Yeah. Okay. All right, so we have, then for this one, we get the same answer, except it's going to be 4.6 times 10 to the 5 joules, because there's only 2 significant digits using this way. So just look at what they did. Okay, you can give them some marks in and around there. Because it was 4.85 when we didn't use the 18. The 18 only had 2 significant figures. Sorry. Yes, it should be 4.9. Okay. I should have drank all of my coffee last period and did not. Okay. Good catch. 4.9, not 4.6. All right. Any other questions on that or any other mistakes I made that you found?
I was just wondering why you did force times distance instead of force distance.
Because I'm using F parallel up here. Okay. It's not a question where I have the horizontal component doing the work, right? It's not, in this case, the force and the work are in the same direction, both up the ramp. So I don't have an angle. I have to use an angle to find that force, but it's not an angled force. Yeah. Yeah. You only use F cos of theta times D if the work and the force are in opposite directions. In this case, F parallel is doing the work in the same direction it's moving. Okay. All right. Any other questions on that one? Okay. Okay, our second question, we got Wile E. Coyote on a set of rocket-powered roller skates. Okay, if you've seen this one, it's one of the tricks he tries in addition to like the large, comically large rubber band and all the other ways he tries to go as fast as the Roadrunner. Okay, so what we have here is we have a mass of 38 kilograms. We have an initial speed of 0 meters per second. We have a final speed of 95 meters per second. Okay, we're looking for how much work the rocket does. Again, there are 2 ways to solve this problem. So 1 mark for givens. The quickest way, work is a change in energy, in mechanical energy. However, in this question, only which kind is changing? Kinetic is changing. Okay, so EK. So we will have then that work will equal 1/2 mvf squared minus 1/2 mvi squared, and that's 0, so it doesn't matter. Okay, all we have to do is plug in numbers to 1/2 mv squared. So 1/2 times the mass, which was 38 kilograms, times 95 squared. Okay, so we have 2 significant figures in this question, so we're looking at 1.7 times 10 to the 5. Okay, we'll say that's your 4 marks. 1 for givens, 1 for showing work's a change in kinetic energy, 1 for plugging in your numbers, and 1 for the final answer. Okay, so that is a question with really 1 step to arrive at the final answer, if you do it using work energy theorem. There is another way to do it. Takes a lot longer. Okay, first thing I've got to do is find the acceleration of the, I can't even do it the other way. I don't have enough information to do it the other way. I can't use force times distance for this one because I did not give you a time or a distance in this question, so there's no way to do it the other way. That was the only way. Thankfully, it's the faster way. Okay, so quizzes out of 8. Give them a mark out of 8. Right at the top, bring them up to me, and then take out what we were working on yesterday. We were working on some potential energy questions.